estimate volume by revolution. This is the volume of a solid that results when the region enclosed by the curves is revolved around either the x-axis, the y-axis, or a point.
To know if the problem requires volume by revolution, look for the words revolve around in the problem. The generic setup for the volume by revolution is this.
So we will be finding the volume generated by the question stated here. So find the volume of the solid that results when the region enclosed by the curve is revolved about the x-axis. And you're given the equations y is negative x squared plus 2 and y is 1. So since the question states that the curve is revolved about the x-axis, you can come over here and fill in dx, and this would be the rightmost x for the bounds, and this one would be the leftmost x for the bound.
Okay, so we're going to use these equations to draw a graph. So we're going to start off with this one, y equals negative x squared plus 2. So we're going to go over to the graph, and we're going to draw that, and that's right there. Then the next graph is y equals 1, so we're going to draw that right there. Oops. Then we're going to shade in the region that is between the curves, so it's right here. So then this is going to be the shape we're going to use to find the volume, and we can use the graph to find out which is the outer and the inner. And since it revolves around the x-axis, the y equals negative x squared plus 2 is the outer, and y equals 1 is the inner.
To get the bounds of the integral, calculate the two x values of where the curves intersect. In order to do this, we will plug the two equations into your y equals menu. So you'll put one into y is 1 and the other one into y2. And then you can graph the two equations. And here you have them curved. A recommended window to clearly see the intersection points would be to have y go from negative 5 to 5 with an interval of 1 and the same values for x. When you have the two graphed, hit second then trace and go down to intersect, and then you can choose your first curve, the second curve, guess, and then it will give you the x value of negative 1. To find the second one, you'll do the exact same thing, and you will go closer to the second intersection point, first curve, second curve, guess, and it gives you the other intersection point of x is 1. So you have these two, and that means that your bounds for your integral will be negative 1 and 1.
Okay, so then we plugged everything into this equation. Then you put your bounds here, so your right bound is x is negative 1, or x is 1, sorry, x is 1. Then your left bound, x is negative 1, and that's where they intersect. Then you plug in your outer equation, the negative x squared plus 2, because that's the furthest away from the x-axis. Then minus your inner equation, x is 1, which is the closest to the x-axis. Then dx, because it's revolving around the x-axis.
To calculate this integral using a calculator, you will need to hit alpha and then the window button. You'll go down to the fourth option, and then to get the pi out in front, you go over, click second, delete, and then second, then the caret button, and that gives you the pi symbol, and then you fill in the rest based on the integral that you generated. So negative 1 would go here, 1 would go there, and then you'd create a parenthesis for the first equation, negative x squared plus 2, then you'd close it, make it squared, add the second, or negative sign for, or subtraction, then you'd add the second equation in, and then make it dx, and then you hit enter. And your answer should be 11. Okay, using volume by revolution in general, this would be the very basic simple equation. Now, if there's a vertical line that it's being rotated around, which looks like the y-axis, you will use the y variable in place here. And there, I guess, looking like this, with the top y and the bottom y as the bounds, and dy as the variable. Now, if you are revolving around the y-axis, you're done. That's all you need for your integral, as long as you fill in those blanks. But if you are revolving around a line, it will need to be in the integral. The line that you're revolving around will need to be an integral. So based off of the outer minus inner, you will use the rightmost, as in comparing the line being rotated around and the outer function. You will do the right one minus the left one, and then compared to the inner one and the line being revolved around, the right minus left. And once you have that all filled in, that is it.
Okay, so using the volume by revolution, we're going to go through the x variable. So you're going to use the x variable if it's a horizontal line, like the x-axis, then you'd plug it in there, and the bounds, depending on what it is. Then this is the equation. You would have the right x and left x, then you would add dx at the end. Then if you're revolving it around the x-axis, you're done. Then if you're revolving it around a line instead of the x-axis, that'll have to go into the integral. So then you'd still have your right x and left x, then dx at the end. But then for your, this is still the outer function, so for the outer function, you would do the top line minus the bottom line compared to the line that you're revolving around. Then for the inner, you would do the top line minus the bottom line compared to the inner line.
Thanks for watching.